Hey, I'm Aaron Calgary, the software engineer for the Blackbears. I make sure that our hardware interfaces together through software and that it all works correctly. When my teammates have questions about the software, I generally have an answer for them.
My name is Khanda Kadir, and I was the project manager for our team, the Black Bears. I was in charge of managing the day-to-day tasks that we would be doing to stay on track this semester, and when it seemed like we weren't working fast enough, I did all the planning necessary to get us back on track in time.
My name is Johnson-Cantrell, and I was a hardware engineer for our team, the Black Bears. I drew up the circuit diagrams, and when it was time to solder everything together, I did, as many times as it took to get it all together correctly. When it was time to put together the final device, I was the one that supplied the measurements necessary to get the job done.
And hardware engineer here, Caleb again, and I am going to give a quick rundown on how we got this fully soldered and powered circuit from this circuit diagram by giving you a quick rundown of the parts involved and how all of these parts work together to accomplish the task, which will be further explained by our software engineer, Aaron, in the next section. So first, just to list off the components that we have here. We have at the centerpiece an Arduino Nano, version 3, obviously. That will be the centerpiece when it comes to the logic and design of the rest of the circuit. We also have a generic HC05 Bluetooth module that will be used to communicate between the two breaks so that the braking sequence is synced up so that no sort of erratic or dangerous behavior occurs during the braking sequence. Because in an emergency, braking needs to happen simultaneously. The same amount of pressure needs to be applied at the same time in order to ensure that the wheelchair does not undergo any erratic changes in direction so that the user can remain safe. We have an Adafruit LIS3DH accelerometer here that measures the acceleration of whatever it happens to be attached to at the time, in this case, a wheelchair. And this number can be integrated to find the speed of the wheelchair at that given time. This speed is what's being used to calculate whether or not the chair is being operated at unsafe speeds. And will also be the indicator that the braking sequence needs to begin if this number is too high. We also have two 9-volt batteries providing unregulated power to both the Arduino Nano and the linear actuators motor, which powers the extension and retraction of the motor based on the open or closed status of these two relays here. Speaking of, this set of two relays, pretty cheap relays, that is 5-volt input, takes a 5-volt signal input from the Arduino Nano and flips a switch based on whether that input is a high or low. And this input and switch will determine whether or not the motor will extend or retract. Lastly, even though it's been mentioned multiple times, this motor here is the centerpiece, besides the Nano of course, of the circuit, because it will be the part of the circuit that actually brakes the wheelchair in case of an emergency. Now, Aaron goes into more detail about this during his code overview, but I'll give a generic rundown of the logic used to brake the wheelchair here. So after the Arduino Nano is powered on, and by extension everything else in the circuit, the Arduino Nano will read from the accelerometer the acceleration of the wheelchair that is attached to, integrate it to a speed, and use this speed to determine whether or not the wheelchair is being operated at safe speeds for wheelchair use. If this safe speed is deemed to be surpassed, the Arduino Nano will communicate to the Bluetooth module the master Bluetooth module, that it needs to initiate the synchronization with the slave Bluetooth module so that they can both initiate the braking sequence at the same time. The braking sequence consists of signals being passed to one of these two relays. I don't recall which at this time. But one of these relays will open. The motor will force the linear actuator to extend, and after some time, the linear actuator will extend into the wheel of the wheelchair, at which point it will eventually stop extending so as not to put too much pressure on the wheelchair until the friction of the linear actuator causes the wheelchair to start to slow. Concurrently, the Arduino Nano will still be reading the speed of the accelerometer here, the acceleration of the accelerometer here, and integrating it to speed so that it can determine whether or not the chair has returned to safe operating speeds. And once the chair has returned to safe operating speeds, it will send a signal to the relay that opened to close, and the relay that remained closed to open, so that the motor will reverse and the linear actuator will begin to retract. Once the linear actuator is fully retracted, the action will stop because both relays will switch to closed, and the Arduino Nano will return to its normal reading of the accelerometer to determine whether or not the loop needs to be initiated again. And that is the gist of how this chair brake works on a hardware level.
Hey, it's software engineer Aaron Calgary here, and today I'll be showing you the code behind our projects. To begin with, a little explanation behind Arduino as a programming language. Arduino as a programming language is actually a C/C++ coding block styled Java-based programming language, which is based on processing and animation rendering Java-based programming language, which is also in turn based on wiring, another Java-based hardware programming language. We use #define in Arduino to tell the compiler to, before compiling, take whatever the first argument is, look throughout the text, and replace it, any instances it finds, with the second argument. What this does is help remove memory overhead on the microcontroller versus a static final constant in Java or other programming languages. We use #include much like we use Java importing, and for the required imports for this project are the wire library, the Adafruit Liz3DH library used for the accelerometer, and the Adafruit sensor library also used for the accelerometer, and the software serial library. We could have used the existing UART hardware serial pins built on almost every Arduino. However, it becomes very hard to debug or re-upload to the Arduino without physically releasing those pins, and as this is a soldered project, it's better if we just move those TX-RX pins to another two set of pins. So we use the software serial library to create two emulated serial ports to communicate with our Bluetooth module. The benefits of using the software serial library is that we can now also use the serial monitor to help debug the Arduino, and because we're not bogged by the releasing every pin per upload, we can now rapidly test modifications to the code. The Adafruit libraries allow us to create a accelerometer object that allows us to also integrate our current acceleration into a running speed double down here. The integration of speed also requires finding the difference in time between this reading and the last reading of the acceleration. So every time the microcontroller loops, we also calculate that as well. Because we have a master-slave pair of motors, we actually use a boolean called master to modify the behavior that is looped through per board. The master motor calculates the speed, decides when the speed is too fast and pushes the brakes, and also sends a Bluetooth signal to the other slave motor when to push the brakes as well. This will sync them up, hopefully. The slave motor just waits to receive a signal from the master motor. That's it. Controlling the motor typically requires many transistors or 2 relays. 2 relays allow us to reverse the motors, which we don't want the brakes breaking constantly. Now, the relays that we bought are cheap in Chinese, so they don't have the choice to be high or low trigger. They are always set on low trigger. So, in order to disable both of them in the beginning of the scripts, we actually we bring them high, and then to decide whether or not to push or pull the motor, we use a right relay method that takes a care state as input, decides whether or not this state is already currently in effect, and if not currently in effect, it will it will turn both relays off and turn the LED on the Arduino off. Then, based on the argument given, if it's 1 or 2, it will choose one of the relays to turn on, and also turns the LED on. Build the appropriate circuit diagrams, upload this code to both of them, changing the master variable as needed. Having a little technical difficulties, but that's fine. Basically, change the master variable in script per board, upload them, make sure that the Bluetooth modules can pair with each other, and you'll have yourself an automatic wheelchair brake. Thank you and have a good day.
We're outside now with one of our brakes so that we can show a live demonstration. Due to some slow moving from our benefactors, we do not have a wheelchair for this demonstration. As the bike that Aaron's riding passes 3 meters per second, the brake will activate, slowing down the bike, and will disengage when the bike comes under 3 meters per second.